Hello everyone, welcome back after 2 weeks. Sorry, last week I was because of the cold. I'm a little bit sick still, but good overall. And also, it was Halloween. I stay at home, but I know like everyone was out, so perfect. And also, the week before, I had some problems with the audio recording. I spent an hour and a half today trying to fix it, as well as the screen sharing in Discord. But if like in Discord you can like see my screen, but you can hear me, just after like watch the recording, send like like there is a question channel. Send any question you have in there. I'll answer it. Like I promise. Now to go a little bit over what we did last week. Last week no, the one before. I know like you guys couldn't like hear it, but this is basically like area formula, perimeter, um, more or less that you can watch the video and see like the specific questions. But basically, yeah, I don't think I have time to go over everything that I did the other week. So my like today, like I'll go over it if I like do this really quickly, and then I have time to review because we're finishing package one finally. So just keep going. I'll keep on doing perimeter area, all of the things. So 61. So Tammy is looking to enclose a dog pen with a fence. Okay. The pen is shaped like a quadrilateral and is modeled on the coordinate plane below. Okay, this is the plane. Very well. So where each unit represents 1 foot, what is the perimeter of the quadrilateral round to the nearest foot? So basically, you see, this is the fence that we have like right here, and this is what we need to do, like what we need to I'm sorry, my okay, never mind. So what we need to do is to calculate the perimeter rounded to the nearest foot. So each unit is 1 foot, so we're fine. Now we have this. I was explaining before that we don't really need to use the distance formula for this. So we have like each square is 1 unit. So I'm gonna do this. 1, 2, 3. Okay, this is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11. And we use the Pythagoras theorem. And these are the catetes, and we want to find the hypotenuse. Or basically, these are the sides we want to find the big side. Um, and we say that square root of one side square is 3, 3 square, plus the other side square, which is 11 square. Is going to be square root of 3 squared is 9, 11 squared is 121, and this is going to be 130. Like a square root, the 130. And yep, that's our answer. That's the measurement of this side, 130. Now on this other side, we do the same. We have 1 and 2. Okay, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 and 9. We do the same Pythagoras theorem. We get square root of 2 square, like one side square, plus the other side square, which is 9. This is going to be a square root of 2 squared is 4, 9 squared is 81, so 4 plus 81, and this is a square root of 85. Okay, now for this side, we have 1, 2, 3, 4, 5, 6. So this is simply 6 because we don't have any angle to work with. This is only a straight line. And now here, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, which is the same of this, like 11 plus 2. But yeah, 13. And now to calculate the perimeter, we just need to add the sides. So we said 13 plus 6 plus square root of 130 plus square root of 85. Since those were, okay, I didn't put it here, 85. Those were the measurements of our side, like of the side of the quadrilateral. Yes. We'll do our calculators since we, like, by our mind doesn't know how to add a square root of 30 and a square root of 85. So we go to our calculator. We say, okay, was it 13, right? Okay, 13 plus 6 plus, okay, let me go to the calculator. It's going to be easier. 13 plus 6 plus a square root of 85 plus a square root of 130. And we get 39.6. 39, okay, this approximately 39.6. Now, that's the important. This is going to be the important part because if you only put 39.6, that's wrong. That's not the correct answer. And why? Because this said from to the nearest foot. So it cannot have a decimal in there. Like it, if you're talking about the nearest foot, it cannot be any number point something. It just needs to be a whole number. Now by our rounding properties, if it is 5 or greater, we are going to add 1. If it's 4 or less, like from 0 to 4, we're going to keep it like this. So in this case, since if this part is greater than 5, this is greater than 5, we add 1 to 39, 39, and our answer is 40. Yep, that's it. That's all we needed to do. Now keep going. 62. Oh, I think this area. Good, let's see. Okay, Mersken. Okay, Miss oversees designing the plans for the new community garden being built in her town. She designs the garden in the shape of trapezoid and plots. Okay, her plans on a coordinate grid with vertices. Okay, these vertices. Now, if each unit on the grid represents 1 foot, how many feet of fencing are required to put the fence around the garden? Okay, count to the nearest hundred of foot. Okay, if you see 100, you see like 100 is 100. So every time you say 100, it just means something, point, space, like the amount of zero. Like in 100 or 2 zeros, so you need like 2 places after the point. I hope you understood that. Anyway, just you have any question, go to Discord and ask me. Like in the question channel, I answer it. Basically, okay, the keyword here, it says around. What does it mean around? It means this. Okay, this is one, da. This is around. Like this is around the shape, the trapezoid. So what do we need to do? We need to do the perimeter. You want to go around the figure without touching anything inside, what we need to do is simply the perimeter. So we go here, we say, okay, like make sure, always make sure that, okay, each square is on 1, and in this, each square is 1, so I'm only going to count them. I say this is 1, 2, 3, okay, this is 3. This is 1, 2, 3, 4, 5, this is 5. This is 1, 2, 3, 4, 5, 6. This is 6. Now this one is a diagonal, so I'm going to need to calculate it. And I have 1, 2, 3, 4, 5. Okay, 5. 1, 2, 3, and 3. So since I want to know this side, I'm going to say, okay, the square root 5 square plus 3 square. And this is smaller equal the square root of 25 plus 9. You see, 5 squared is 25, 3 squared is 9. Now 5 plus 9 is 34. So this is going to be a square root of 34. Um, to calculate our perimeter, what we're going to do is say 3, 3, okay, 3 plus 5 plus 6 plus this side, and this side is a square root of 34. So this is going to be a square root of 34. Now, remember what I was telling you. It says round your answer. So we need to keep that in mind. Now it is specified where? To the hundred. So it's 2 point, like 2 spaces after the point. So when I go to my calculator, I'm going to say, okay, let me delete this. Okay. 3 plus 5 plus 6, right? Yes. Plus a square root of 34. Now it says 2 places after the point. So I'm going to say, okay, this part right, like this 0 doesn't count. Doesn't count. So we're going to, okay, weird. And 2 places after the point will be 83. So my answer is 19.83. And this is what they are asking for. Now, where is the area of the community garden? Okay, so they are asking now the area, and the area is all this space inside. All of this is the area. Okay, wait, I'll put this here. So all of this space inside is the area. Now you might say, okay, but I don't have a formula to calculate this. This is a like weird figure. Like there is a formula, but I don't know it by memory. What can I do? What you could do is just divide this in the. Now we have a square right here. This is a square. Like an rectangle. Sorry, this is a rectangle. I know my area formula for a rectangle, and this right here is a triangle. I also know my area formula for a triangle, so I just can calculate them and add the area, and that's it. I'm gonna get the answer. So first, for my rectangle, I know this is 3. Like this size right here is 3, and this side right here is 5. So my area is equal base. I like to say base time height. Base time height. So this is gonna be the base. They are the same size because it's a rectangle. So this is also 3, and this is also 5. So this is going to be 3. Wait, 3 times my height is 5. So 5 and 3 times 5 is 15. Now the area of this is going to be 15. Okay. Now what about the triangle? First, this big like you can only count. You will say, okay, I need like my area for like formula area. First, I'm gonna start with that. My formula area for the triangle is equal base times height divided by 2, or area equal 1/2 of base times height. Either way, you're going to get the same answer. Use whatever you feel more comfortable with. I like better this one. It's exactly the same. Like, exactly the same. I just like that one better. Do whatever you think is best for you. Like whatever will work best for you, that's what you're gonna use. Now, keep going. Okay, we need the base, we need the height. So the short one and the middle one. If it is a right triangle, which in this case it is, like it's a horizontal line and a vertical line. It's just perpendicular because in like in algebra, you might like from algebra you might have known that if you have a horizontal line, which is the horizons, like aligned with the horizons. That's what I like to think to remember it. And then you also have a vertical line, which is the opposite, like from the top to bottom. They are going to form a 90 degrees. That's how it works. Like one has a slope of 0, this one has a slope of 0, this one has a slope of undefined. But that doesn't matter for us right now. We just need to know that since it is a right triangle, for the base and the height, we can just use the small side and the middle side, not the hypotenuse, which is the big side. So we need this one, which I can 1, 2, 3. So this is going to be 3. Also, you can say 6 minus 3. Then you're taking apart this part. So 3. And then we had this from before is 5. We are going to substitute our value. I'm going to get that A is equal 3 times 5 over 2. Now 3 times 5 is 15. And 15 divided by 2 is 7.5. Of the area of the rectangle, we have the area of the triangle, and our total area going to be um the like the two areas adding together. If we want to know the whole thing, so the two areas are added together will be 15 plus 7.5, and this is equal 22.5. And that right there is our answer. Yep, that's all we need to do. Keep going. Yeah, we're almost finished. Sorry. Rosa is building a flower bed for her mom in the shape of a parallelogram. Okay, a parallelogram. I read the word and I'm thinking about this. Okay, we have a parallelogram. Now, when drawing the coordinate plane, the flower bed has vertices. Okay, has those vertices. Now, if every unit represents a foot, where is the area of the flower bed? Now, okay, I'm going to go back. It's going to be easy for you one of these. Tu, tu, tu. Please. Oh, sorry. Going from -4 to negative to 2 and -6 to 6. So it's better this way as well. Sorry. Okay. Ugh. We're gonna get like one point out of the graph, but it's going to be okay. Anyway, so we draw this. Here, here. Okay. Now, -4, 0. Alright, but like, wait a second. Okay, take too much time drawing this thing. -4, 0 will be right here. Then -2, 6. Okay, -2, 6. Now 4, 0 is going to be over here. I know, that's the best I could do. Now 2, -6. So 2, this is going to be 0, and -8 will be here out of the graph as well. Sorry about that. Now we have this parallelogram. Okay. Now to make the to draw the like to use the um area. I don't know why I forgot the word area. So for parallelogram, I'm going to draw one right here. Okay, this is a square. No, parallelogram. Okay, right here. And the formula for the area is going to be base times height as well as the rectangle. The thing is that this is going to be the base. Okay, one side is going to be the base. Now the height will be the line perpendicular to that side. This is going to be the height. And the thing is that like this side right here is not the height, and if you use that, it's going to be wrong. So you need to be very careful with that. So this is the base, that's the height. And in this case, what I will do is, okay, look at this. Okay, one second. If I do this, mm, 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 oops, let me take the point with me. Better. If I do, it's not letting me. Okay, this is weird. Okay, it's not letting me. But if I like kind of flip this, is where it didn't let me. We can see that the height be right here. Okay, no, never mind. Yeah, this will be the height. Use the perpendicular line, and this will be a 90 degrees angle. Since as you can see here, the slope is basically with the slope. The slope of this one is going to be 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. 6 over 6. And then rise this side. Rise over run. And it's going down, so negative is going to be -1. 6 divided by 6 is 1. So the slope we want to know for the perpendicular line, as I have explained it before in other videos, is a slope is a reciprocal opposite, which in this case it will be like the reciprocal of 1 is just 1, and since this is negative, we want a positive one. We want it going up. So as you can see here, the slope of this line is 1. It is 1, 2, 3, 4. 1, 2, 3, 4, and 4 over 4 is 1. And that's basically how I knew that was uh, the what I was looking for. Okay, I deleted this where we need it. Now the formula is area. Okay, I'm going to move this right here, so it's not in the middle. Area equal base times height. We need to calculate the base, like the area, like the length of the base and the height. I don't know what I said. But as I did before, we use our Pythagorean theorem. We say, okay, I need the line. I have the sides, so square root of 6 squared plus 6 squared. This is square root of 6 squared is 36, 6 squared is 36, and this is square root of 36 plus 36, 72. Okay, that's my line. That's this line, 72. Now I need the other one. I do the same, have my square root, and move this around, and make it smaller. Okay, better. Now I have the square root of 4 square plus 4 square. And now I say, okay, 4 square is equal to 16, so the square root of 16 plus 16. And then 16 plus 16 is 32, so we get the square root of 32. And now, what we are going to do is to multiply these two values. So this is going to be a square root of 72 times a square root of 32. So we go to our calculator. Root of 72 plus it. Now a square root of 32. And we get 48. And you might be thinking, wait, there is another way like to do it without the calculator. Well, we still need to calculator for that. It's just another way to do it. Never mind. It doesn't matter. So we got the area is 48. And this right here is our answer. That's all we were looking for. The area of the parallelogram. And what I meant before is that since no, never mind, it doesn't matter. So we get the area 48. That's our answer. You can see here is option C. Okay, I'm sorry for the good. I started to overanalyze this, and I forgot that we're in geometry and we don't need to do a lot of stuff I was doing. So that was my bad. It's just a simple exercise. Like you saw that we got that our answer was 140, like it was 48, sorry, but it's square. I just didn't put it here because you said it is here for the square. And now I'm reading, okay, part B. If the plant tag recommends that for 6 inches spacing you need 4 plants per square foot, okay. How many plants do you need to cover the flower bed? Okay, we have that, like we have 4 plants per, what I was like, I did explain this right, so I'm going to do it again. So every time you see the word per, I'm just going to do this, okay, a fraction. Now a square foot, okay, for 1. It don't say 2 square foot feet. It don't say 6 square feet. It says square foot singular. So I'm going to say, okay, 1 square foot or foot square, like, yeah, square foot. Okay, this is what it says the problem. And we have that our area is 48 square foot. So I'm going to multiply it times 48 square foot. Now, square foot divided by square foot is nothing. It cancels out. So we cancel out this and we get 4 times 48. When we have the plants here. So 4 times 48 is just 192 if I'm not mistaken. Okay, ignore this. 4 times 48, yeah, 192. So 4 times 4 is 192. We cancel out the square foot, so we get 192 plants. And that's what they were asking for. How many plants per square foot? And that's the only like we needed to do. And this right here is our answer. Pretty easy. Let's go. We're only missing 2 more. That's great. Perfect. Now, triangle ABC with coordinates, is graphed on the set of axes below. Okay, perfect. Where is the area in square unit of triangle ABC? Okay, now it comes the interesting part. Remember what I was telling you before? That we could use the sides of this triangle because this was a right triangle. But right now, I can say this is not a right triangle. So we need to use the normal formula, the actual formula. Well, it is still the same. It is area equal base times height over 2 or 1, or remember you use the ones that you're more comfortable with, 1/2 or 5 times height. It's the same, exact same equation. I'm just reading in a different way. And I'm going to say, okay, like we could use either side of the base, but I will really recommend use the longer one. That's the easiest to do. So you say, okay, this is gonna be my base. I want the length of the base, and after that I'll figure out the height. But for now, the length of the base. So 1, 2, 3, 4. Okay, I'm gonna use another color. So. Okay, let me just check something. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, 12. Let me check something. Okay, perfect. And 1, 2, 3. Okay, this is 12. This is 3. And we need to calculate the blue part. So we say square root of 12 squared plus 3 squared. It's gonna be square root of 144 plus 9, like 12 squared, 144. 3 squared is 9. 144 plus 9 is 153. So square root of 153. And that's our base, 153. Now we need our slope. Calculate the perpendicular, like the perpendicular line. Okay, that's what we need. Sorry. So the height, let me explain it well. The height of the triangle is going to be the perpendicular line, like to the base that pass through the opposite point. So the opposite point will be A, because that's the one that is in the contrary of the base we choose. And now it needs to be perpendicular to the base. So it needs to be something like that. But let's not draw anything until we get this slope. So we are sure that's the line we're looking for. Now our slope is rise over room. This is rise, so 3. This is room. Like remember, rise over room. So 3 over 12 is positive because it's going up. Like this one right here will be negative because it's going down. But this one is going up, so it's positive. And we divide both sides by 3, and we get like 3 divided by 3 is 1. 2 divided by 3 is 4. So this is 1 over 4 over 4. And that's our slope. Okay, everything perfect. Now we need to calculate the perpendicular line. So we need the opposite reciprocal slope of this line. So first, okay, the force in the bottom, so the force goes up, and then force over 1 is 4, since the one goes down. And now this was positive, so we needed negative now. And this is negative. Now, our slope is rise over up. So it will be 1, 2, 3, 4, down, because it is negative 1, because this is 4 over 1. So this is what, like, this is gonna be what we are looking for here. So I'm going to come here and I'm going to say, okay, minus of negative 1 over 4. So 1, 2, 3, 4 down because it's negative until here. And now 1 to the side. And we get this point right here. Good. Let me check something. It is not on the line. Ah, that's pretty bad. Yeah. Then we'll need to do more calculations to make that right. We like, of course we could. It's just that it's a lot of calculations. No, it's not a lot. It's just that I don't want to do it. But okay, okay. It's not on the line, so we need to do another thing. That happens, so I'm gonna teach you how to do it. Either way. Now pay attention. This is important. So we got our new slope, and what we want to do is find an equation for a sorry for a new for a line that passes through this point with this slope with negative 4 as a slope. I'm going to use my the equation we was using before. So y minus y1 equal m x minus x1. I'm going to need to use it twice. Maybe there is another way to do this. I don't know right now. I can't tell you about that. So okay, this is what we have. Okay, y minus y1 will be okay. A is negative 1.5. So y1 5 equal x is m is negative 4. Okay, x minus negative 2 minus minus positive, so plus 2. Okay, y minus 5 equal sorry, sorry about that. So multiply negative 4 times x, negative 4x, negative 4 times 2, opposite sign, so negative 4 times 2 is 8, so negative 8. Now we add 5 in both sides, so we can cancel out this. And we get that y equal negative 4x. Now negative 8 plus 5, they have different signs, so we subtract each other, so 5, a minus 5 is 3. Now a have a negative sign, so our answer will be negative. It will be minus 3. And this is the equation for that line. Okay, another color. This is the height. This is the equation for the height. Now, um, we also want the equation for the base. This is a really hard question. Like really hard. So we want the equation for the base. We know the slope. We know one of the point. I'm going to use the easiest one, which is this one right here. Is 0, comma 1. I know like it's not like C or B, but we could see easily on the graph, and it's the easiest one to use. So I'm going to use that one, and I know that my slope for this one will be 4. So 4, like never mind, y minus y1, and y1 in this case will be 1, so y minus 1 equal m will be 4, x minus, now my x is 0, 0. So y minus y1, like y minus 1, equal 4 times x for x, 4 times 0 is 0. So I add 1 in both sides and I get that y equal 4x plus 1. That's my other equation. Now to know the point they both intersect, because I know it's going to be something like this. Another color. So it will be something like this. Basically, I'm trying to make it perfect. This is not working. So more or less, so it's going to be intersecting the other lines in a weird point over here. So to know the coordinates for that point, we just made the two lines equal, at least for the x coordinate. So we say, okay, they are both equal to um okay, this was 1 hour. Okay, my bad. I just remember the slope of the normal line. This my slope here was 1/4. Okay, this is 1/4. That was my bad. Now you skip the 1/4 here. We made like they are both equal to y, so we made both equal. Okay, they are both equal to y, so I can say okay, negative 4 like 1/x plus 1 is equal negative 4/x minus 3. So I'm gonna add 4 in both sides. when I add 4 in this side, it's going to be 17 over 4x equal. Now I'm going to subtract 1 in each side, will be minus 4. Like minus 3 minus 1 is minus 4. We keep the sign, we add them. And in this side, see what I was explaining before of like 1 over 4 plus 4. Then no, common denominator, wait, it's 1 over 4, yeah. It's 4, 4 divided by 4, 1. 1 plus 1 is 1. 4 divided by 1 is 1, 4. 4 plus 1 is 4, 8, 16. 6, 17 over 4. Yeah, that's basically what I did. Okay, keep going. And then we multiply both sides by 4. I got the 17x equal negative 16. And then x is going to be negative 16 over 17. That's our value for the x. This is the x coordinate. And if we want to know the y, we take any equation. I'm going to use this one. Y when x is negative, like y equal with negative 4 times, I'm going to substitute the value for the x, negative 17 over 16 over 17 minus 8, minus minus positive, so 4 times 17 will be y equal 4 times 17 is 64, then over 17, like 4 times 16, so 64 over 17 minus 8. Sorry, I need to use my calculator right now. More or less. Wait, I need to do something first. So 64 over 17 minus 8 will be 12 over 17 is 64. So 17 divided by 17, 1. 1 times 64, 64 minus, we keep the sign. Now 17 divided by 1, 17. And 17 times 8, 136. And this will be different signs. So we subtract them. 136 minus 64 is 72. Now, 136 has this negative sign in front, so this is negative, and we keep the denominator. Let me check. I did it right. Okay, negative 6. Okay, I did it right. Over 70, and I don't think this can divide. No, definitely no. So these are our coordinates. It will be minus 16 over 17, comma, negative 72 over 7. And that's our coordinate for this point. Now that we know the coordinate, we can use, okay, no, it's this one. My bad. We can use the distance formula to calculate the, distance of that side. This is what's called. Okay, I'm gonna do this next class as the first one. So distance formula equals square root of x1 like minus x2 plus a square y1 minus y2 square. This will be x1 negative, okay, what did I put it? 1 second. Here, negative 16 over 17 minus, now the negative it is negative 2.5. So my other x minus a minus positive, so plus 2 square plus my y1 will be, well, dun, dun, negative 72 over 17, negative 72 over 17 minus 5. So we add this together, and in this case, we got 18 over 7 squared plus, now negative 72 minus 5. Sorry, I need to do it in this side. I don't have, okay, here. I'm doing the bottom. Negative 72 over 17 minus 5. Same denominator.
Joder.
We 17 divided by 17, 1. 1 times 72 is just 72. We get the sign. Minus 72 divided by 1, 17. 17 times 5, it will be 85. So 85. Mine, like, since they have the same sign, we add them together. And 72 plus 85. Oh, wait a second. 157. So negative 157 over 17. Like we put it here. This is negative, but remember, like, we're square now. 17. And this is square, since we're using the distance formula. Um, we can use a calculator for this, definitely. We're going to get an estimated value, or we can use, I can plug in, like, I know that this is going to be the height. It's going to be the distance of the height. So I can just plug in the equations. And I think will be easier to put it on the calculator like that. I'm going to do it right now. I know that the area is base times height over 2. So this, my base, it was a square root of 153. So 153. Now I have my height. My height will be all of that. So I'm going to plug in all of that. Okay. It can seem scary, but we have a calculator for something. So 18 over 17 square plus negative 157 over 17 square. This plus the square. Okay. Now all of this divided by 2. I'm going to go to my calculator. Okay. And it will be square root of 153 plus the square root of important. This is important if you don't have, like, something that can put fractions, as I, like, this calculator doesn't do. So this will be, we put the parentheses, and I will say 18 divided by 17, and close parentheses, square, plus open parentheses. You could put the negative or not, it will become positive, simple, like, we're squaring it. Every time you rise any negative number to an even number, it will be positive. So that's the reason, but I'm going to put a negative just so you can see. Divided by 17, we close it, we square it, we close everything, and this is our answer. Now, we haven't divided by 2 yet. Like, we got that. We got that this in the upper part was approximately 21 point. Do they specify where they want? No, they don't specify where they want to square it. So this is 21.67. I'm gonna say it was 67. Yes, 67 over 2. Remember, I haven't done, like, Yeah, I only did the only like the upper part. So over 2. So now I take my result, I divide it by 2, and I get this, a 10.8, which like I can approximate. I will say that A is approximately 11. And this is my answer. So I go here and I say that the area is approximately is like 11 square units. It was a lot. I know it was a lot. But that's how you do it. If you find an easier way to do it, maybe I would just like my cables in my mind cross because of 2 hours doing this. But yep, that's how I would do it. And since they don't specify how they wanted to like round it, I just write to a whole number. You don't need to like you can round it whatever you want. And yeah, if you have any question, join the Discord. I'll answer. Like there is a question channel, and I check it like regularly and answer any question you might have. I promise. Yeah, that's it. Sorry for all this. I didn't think like they would put an so hard like exercise so hard. Maybe I made it hard. I don't know. Yep. Tomorrow we'll be doing this one, like the first one. Then we'll jump to a new unit, which is great. So bye. Have a great week.